Okay, so now we want to talk about the last section of pre-calculus, chapter 9.5, determinants and cramer's rule. Okay, so the objectives are to evaluate a second order determinant. Actually, I have already give you guys something before in the inverse of matrix. Okay, solve a system of linear equations in two variables using cramer's rule. Evaluate a third order determinant. Okay, and solve a system of linear in three variables using cramer's rule. Evaluate high order determinants. This is only okay, so you understand. It's for understanding. Okay, so these two you guys need to know how to do it. Okay, so the determinant of a 2 by 2 matrix. What will be the determinant of a 2 by 2 matrix? When you have a bracket that is used for what? This is bracket for what? For matrix definition. And this is what? Lines, vertical lines, or what should I do? Okay, so here there are vertical lines. This is for what? Determinant. Okay, so do not randomly write something. Okay, so if you have just write vertical lines, that is not a matrix, that is what? Determinant. So what will be the determinant definition? This is a1 b2 is this diagonal minus this diagonal, a1 b2 minus a2 b1. Yeah, do you remember in the multiplicative inverse? Yeah, a b c d. Yeah. So what will be the multiplication inverse? Is 1 over AD minus BC. So what is AD minus BC? Write it down. Okay, so A equal to, remember, A, B, C, D, yeah? So A inverse, we have what? 1 over AD minus BC. Do you remember what will we do? You interchange that diagonal, negative B, negative C here, yeah? Where the AD minus BC come from? So AD minus BC is actually what? Determinant of A. Yeah, so it is determinant of A. Yeah, so that is what? AD, this diagonal minus BC minus that diagonal. Are you with me? So this is multiplicative inverse, okay, of 2 by 2, okay? So remember this. Okay, so the next one is evaluating the determinant for a 2 by 2 matrix. So what will we do? 10 times 5, this diagonal, minus the multiplication with this diagonal. 10 times 5 is not 69, it's multiply, yeah? So it's 50 minus 54 is negative 4. So the determinant can be what? Can be 0, can be any number. Okay, so it does not need to be positive. So this is not an absolute value. Absolute value is always what? Non-negative. But determinant is not absolute value. It can be what? Negative or 0 or positive. So do not think, did I make a mistake if I have like a negative number? No. Okay, if you follow the instructions, you didn't make a mistake. Okay, so this is another example. Okay, so yeah. Oh my god. Okay, I think it has a mistake. So the matrix should be what? 4, 3, negative 5, negative 8, yeah? Because they give the matrix here, but they give the, the thing here, yeah? Yeah. So how could you find, maybe we can try this one. How could you find the determinant 2, 4, -3, -5? Yeah. So what will you do? It's 2 times what? -5 and minus 4 times what? -3. Are you with me? Be careful with the sign. It's -10 minus 4 minus 3 you plus 12. This is what? 2. Okay, so they are doing, I think, when they arranged the PowerPoint slides, they didn't check it carefully. Okay, so the next one is solving a linear system in two variables using what? Determinants. So we wanted to introduce Cramer's law. So what is Cramer's law? So we use, what method did we learn before? You can either use what? Substitution or what? Elimination method, or elimination method, So now, with definition of matrix, what could we do? You can use what? Cramer's law. So Cramer's law is what? What will be the x and y? What it will be? It will be determinant. This is what? Determinant of the coefficient, of the coefficient. Okay, so then what happens here? If you wanted to find x value, so what will you do? You replace the coefficient of x by the constant. So you replace the coefficient of x by the constant. And then what will you do for the y? You still have the determinant of the coefficient x and y here, Okay, but what will you do? You will replace the coefficient what? Y by the constant. So this is how you remember. This is how you remember. Okay, so then what should we do for this one? Use Cramer's law. First, you always find the determinant of the coefficient, So it's what? 5, 3, 4, -6. It's 5 times -6 minus 3 times what? 4. 3 minus 3 times what? 4. So -30, -12 is -42. And then for the x, so what will you do? You replace all the x by the constant. 12, 24, 4, -6. So is what? Minus 24 times what? 4. So you -72, -96. So what will be dy, guys? So what will you do? So you keep the x, 5, 3, you keep on the x or the first. But your y, 4, -6, will be replaced by 12, 24, So what will you have? 5 times 24 minus what? 12 times what? 3. So it's 120 minus what? 36 equal to what? 84. Are you with me? So what will be x? X will be what? Dx over d. So that will be what? -168 over -42. So what do you have here? 4. So what will be y? It's dy over d. So what will be d? dy 84 over -42. That will be -2. Okay, so it's for 2 by 2 matrix. Okay, so actually Cramer's law is not so easy for 2 by 2 matrix, but Cramer's law will be super easy for high order. It's a 3 by if it's a 3 variable system or 4 variable or 5 variable, it will be much easier. And Cramer's law is also constructed for what? Do you know why we constructed? Is for computer science, because we can always use matrix to code and what? decode. This is how your calculator work. Yeah, how do you think that your calculator can help you to solve the equations? It's about, all these rules that we constructed for them. And then it's on the back end, they have already used Cramer's rule to give you the solution. Okay. So then, we can, this is what 4 negative 2, we have already got it. Yeah. Okay. So the definition, what will be the determinant of a 3 by 3 matrix? Okay. So, okay. So it will be the diagonal of the top. Okay. So it will be A1, B2, C3 plus what? B1, C2, A3. Okay, so it will be always A1, B1, C1 goes first. A1, B1, C1 goes first. Yeah, so C1, A2, B3. B1, C2, A3. Minus what? A3, B2, C1. A3, B2, C1. So that will be, the other diagonal. So which color should I? A3, B2, C1. And then what will you have? It will be the bottom one, B3, C2, A1. And C3, A2, B1. Okay, are you with me? So it will be, how could you see? So, what I noticed, it will be, okay, so for the first 3 positive ones, you always start with A1, B1, C1. So you keep the A, B, A, B, C, yeah, so A, B, C, B, C, A, yeah, so it's always like A, B, C, you rotate. So A, B, C, then the second one is B, C, A, the third one is C, A, B, yeah. Okay, so here is A, B, C too. It's A, B, C, B, C, A, C, A, B, yeah. But here you always have what? The number is always 1, 2, 3, yeah. 1, 2, 3. But here the number is always what? 3, 2, 1. 3, 2, 1. Okay, so this is how you remember. So it's A, B, C, B, C, A. Is that's what, continue, like rotate. Okay, so it's A goes first. Now A goes to the last, and B goes first. Move, rotate. And all the numbers who goes first is 1, 2, 3 for the positive one. 3, 2, 1 is for the negative ones. Okay, so that's very important. Okay, this is how you remember the rules here. Okay, so this, and but if you do not remember the rules, you can also use this definition. Then you use A1. Okay, so what does this mean? If you forget this rule and this column, so if you can delete the row and the column that has A1 on, and then all the others you write it down. Okay, so but for the second one, you need to be careful. It's what? Negative. I will explain why you have a negative here. It's actually it's negative or positive is -1 row plus what? Column. Okay, so for the A1, what is your row? 1. What is your column? 1. So -1 to the 2 is what? Positive 1, yeah? So this is why you have the positive. For the A2, what will be your row here? It's second row. What is your column? First one. So -1 to the 3, which will be what? -1. Are you with me? And similarly, what will happen for A3? It's -1 to the row. What is row here? 3. What is column? 1. So it's -1 to the 4, which will be 2. Oh, no, not 2. Sorry. It's what? +1, yeah? Oh my god. Yeah. Okay, so this is why you have a positive on the first and third, and you have a negative on the second. Yeah, so what will you do? You just forget when you have a2, what will you do? It's what it will become is you forget this row and the column has a2. Then what do you have left? B1, C1, B3, C3. Yeah. So similarly, you forget the A3, you have B1, C1, B2, C2 left. Yeah. And then what will you do? The determinant 2 by 2 is easy. Is B2, C3 minus what? B3, C2. B1, C3 minus what? B3, C1. B1, C2 minus what? B2, C1. Okay, so it's easy, but this one is pretty easy too. For the positive, what do you have? 1, 2, 3, yeah. A, B, C, B, C, A, C, A, B. A, B, C, B, C, A, C, A, B, yeah. So it's rooted. So you just remember, for the plus ones, you have 1, 2, 3. For the minus, you have 3, 2, 1. Clear? So these are the two rules. Okay, so oh yeah, so it has also show you, like, okay, so you forget the row and the columns here. Okay, so now we wanted to practice a 3 by 3 matrix. For the 2, what do you have? What are the matrix that you want to multiply? It's 2 times what? 6, 0, 3, 1, yeah, and minus, because the middle one is minus, negative 5. What is negative 5 left? You forget the J's. What do you have left? 1, 7, 3, 1. For the negative 4, what do you have? Plus, yeah, negative 4. And for the negative 4, what is the matrix that you want to multiply? Yeah, so we have 1, 7, 6, what? 0. Are you with me? So what will you have there? The diagonal minus the diagonal. 6 times 1 minus 3 minus 0 is 6, yeah. Minus is plus 5. So it's 1, 1. 1, 1 is 1 minus what? 21 is negative 20. Minus 4 is here is 0 minus 42. So negative 42. Are you with me? So what do you have? Negative 12 minus 100 minus what? Plus 168. So it's 68 plus 12. It should be 80. Okay, you can do the calculations. Let's check the answer. Oh, good. So we have the answer is 80. Yeah. Okay, so we just do it very quickly with you can we do not need this many slides. Okay, so the next one is, okay, after we find the determinant, yeah, so what will we do? We wanted to find what? Cramer's law, yeah. So what will be the Cramer's law here? So what is D? What do you think is D? Is the determinant or the coefficient, yeah? So D, which will be A1, B1, C1, A2, B2, C2, A3, B3, C3. Are you with me? What do you think will be dx? Do you remember the rule? All the A1, A2, A3 is gone by what? D1, D2, D3. Yeah, so you keep the space, you keep the location D1, D2, D3, B1, B2, B3, C1, C2, C3. What will be dy? So instead of replace x, you replace the y. So you have A1, A2, A3, that's your x. So your B1, B2, B3 is gone. D1, D3, C1, C2, C3. And similarly, what will be your dj? So it will be A1, A2, A3, B1, B2, B3. Your C1, C2, C3, it will be what? D1, D2, what? D3. You with me? So this is, pretty straightforward thing. So, you replace the x coefficient, replace y coefficient, replace z coefficient, yeah? So we just practiced. And here you have, the definition too. Okay, so what will be the Cramer's rule? What will be the Cramer's rule? Find the determinant of all 4 of them, yeah? Oh my god, that will be a lot of work, yeah? So that will be a lot of work. Okay, so you have to do it carefully one by one. Okay, I will not do it one by one with you anymore. You can, practice after the class or after you watch the video. Here you can find the dx, dy, yeah? So, you choose 3. What you need to be careful, the middle one, do not forget what? Minus. So the middle one, do not forget what? Minus here. Clear? You find the dx, dy, dj. After you find it, what will you do? Plug in all these values into the formula. Then you find the solution set is 2, negative 3, 4. 2, negative 3, 4. Okay? Good. So the determinant of any n by n matrix, this will be what? Like the tricky one. Okay? So it will be with n rows, n columns. It will be the nth order determinant. The value of the nth order can be found in terms of n order what? N minus 1. Okay, so the minor of the element aij is determined by deleting the ith row and jth column is given given array of numbers. The cofactor of the element aij is negative 1 plus j. So this is x negative 1 to the power of I plus j times the minor of aij. Okay? So actually they have evaluated the determinant, yeah? So the trick here is, do you always need to go with the first column? No. You can choose any column or even any rows. Okay, so rows we didn't talk about here in this thing, but we will talk about in linear algebra. You can choose any columns or any rows, yeah, and then do this, yeah. So which column do you think it will be the easiest? This one, yeah. So because you only have one non-zero number, which is 5, all the others is what? 0, yeah. So this is why I choose what? This column to start, yeah. This is why they choose this column. Okay, you can choose what? Any column or row to calculate the determinant. Okay, so but for all the zeros, do you need to care? So no, yeah. So you only need to care 5. But what will be the cofactor? Do you remember? It's negative 1 row plus what column? Is the I plus j. What is the row here? 2. What is the column? 1, 2, 3. So it's 2 plus 3. So you have a negative 1 to the 5 is what? Negative 1 times what? 5. And then you wanted to find what are the minors. What means minor is forget this row, forget what? This column, and then the rest of them, that called what? This is your minor. It's also, leftover matrix, yeah? Okay, after you get the, reduce the 4 by 4 to what? 3 by 3, what will you do? Reduce the 3 by 3 to what? 2 by 2s, yeah, using the same formula again. So then, you calculate, use the determinant of 2 by 2, yeah. So for n by n matrix, how could you calculate the determinant? Yeah, use this formula, yeah, to reduce it by a bunch of the sum of a bunch of what? N by 1 times n by 1 matrix, then reduce one more, until you reduce to 3 by 3 and then 2 by 2. Are you with me? Then it will be like, okay, so you can calculate, yeah. And this process is also what? Repeating process. And this is why your calculator can do it so quickly, because computers like repeating work, yeah, so it quickly finish. Okay, but if you wanted to understand what is going on, you need to learn mathematics. We will know what is going on, how the calculator work. Okay, and if you wanted the calculator work for you, basically you have to know the math. Okay, so this will be the end of pre-calculus.